Our bodies are incredible machines. One of the most impressive is the constant battle waged by our immune system. Trillions of bacteria, viruses, and fungi are constantly trying to invade our bodies. Luckily, we have an army of cells trained and ready to defend us. Think of your body as a fortress with walls, moats, and guards protecting it. The immune system is like the defense force of this fortress, always vigilant and ready to repel any attack. It's a world of microscopic battles, with victories and losses happening every moment. Without it, we would be easy targets for any microbe looking for a free meal. So the next time you feel a little under the weather, remember the invisible war raging within you. Your immune system is fighting tirelessly to keep you healthy. Imagine this: you're walking barefoot in the garden, enjoying the feel of grass between your toes. Suddenly you step on something sharp. Ouch! It's a rusty nail and it pierces your skin. Along with the pain, you've also given passage to millions of bacteria lurking on the nail's surface. The bacteria, seeing a golden opportunity, waste no time in exploiting the breach in your skin. They begin to multiply rapidly, their numbers growing exponentially with each passing hour. The very act of the nail piercing your skin triggers a cascade of signals alerting the immune system to the breach. The first line of defense has been alerted and the battle is about to begin. The race is on and the invaders have a head start, but the immune system is mobilizing and it's not going down without a fight. As soon as the bacteria breach your skin, the immune system dispatches its first responders, macrophages. These cells are like the security guards of your body, patrolling the tissues and keeping an eye out for anything suspicious. They are large, amoeba-like cells with an insatiable appetite for foreign invaders. When a macrophage encounters bacteria, it doesn't hesitate. It engulfs the intruder, trapping it within a membrane-bound vesicle. Once inside, the bacteria are bombarded with enzymes and toxic chemicals, effectively digesting and neutralizing the threat. But the macrophages aren't alone in this fight. They send out chemical signals, calling for reinforcements. The neutrophils. Neutrophils are drawn to the site of infection, where they unleash a barrage of toxic chemicals, killing bacteria indiscriminately. This initial response is crucial in containing the infection. Section 4. Calling for reinforcements, dendritic cells and helper T cells. While the macrophages and neutrophils are busy holding the line, another crucial player enters the scene: the dendritic cell. These cells act as the intelligence agents of the immune system, gathering information about the invading bacteria. Dendritic cells have a unique ability. They can swallow bacteria, break them down, and present fragments of the bacterial proteins on their surface. Carrying these vital pieces of information, the dendritic cells migrate to the nearest lymph nodes, which are like the command centers of the immune system. Inside the lymph nodes, the dendritic cells present their bacterial fragments to another type of immune cell, the helper T cell. When a helper T cell encounters a dendritic cell presenting a fragment it recognizes, it becomes activated. This activation triggers a cascade of events that will ultimately lead to the destruction of the invading bacteria. Section 5. Antibody factories, B cells and their arsenal. Once activated, the helper T cells begin to multiply rapidly, creating an army of clones ready to fight. Some of these clones differentiate into memory T cells, which will provide long-term immunity against this specific bacteria. The others travel to other parts of the lymph node, where they encounter another key player, the B cells. B cells are the antibody factories of the immune system. Antibodies are specialized proteins that can bind to specific molecules on the surface of bacteria, viruses, and other invaders. When a helper T cell encounters a B cell that recognizes the same bacterial fragment, it activates the B cell. This activation signals the B cell to start producing massive amounts of antibodies, flooding the bloodstream with these targeted weapons. Antibodies can neutralize bacteria by binding to their surface and preventing them from attaching to and infecting cells. Section 6. Victory and remembrance. Killer. T cells, macrophages, and memory cells. While the B cells are busy producing antibodies, another type of T cell joins the fight, the killer T cell. Killer T cells are designed to directly kill infected cells. Killer T cells are activated by helper T cells and recognize infected cells by the presence of bacterial fragments on their surface. Once activated, a killer T cell releases toxic chemicals that punch holes in the membrane of the infected cell, killing it and preventing the bacteria from replicating further. With the combined efforts of macrophages, neutrophils, antibodies, and killer T cells, the immune system eventually gains the upper hand. The bacterial invaders are destroyed and the infection is cleared. Macrophages return to clean up the battlefield, engulfing and digesting dead cells and debris. Memory T and B cells remain in the body, providing long-term immunity. If the same bacteria ever try to invade again, these memory cells will be ready to mount a faster and more efficient response.